The story you were told about Betelgeuse is no longer the story scientists believe. For decades, we were comforted by a single, solid number, 100,000 years. That was the timeline. That was the cushion that allowed us to look up at the constellation Orion and feel a sense of cosmic safety. But that 100,000-year timeline collapsed 18 months ago, quietly, in a series of professional journal articles that almost no one outside the inner circle of professional astronomy has ever read. The 2019 Great Dimming was not the simple dust cloud the public was told it was. The star itself cooled. There is a hidden companion, a silent killer, ripping the star's envelope apart on a 5.78-year orbit. Mass is bleeding off the surface at a rate that defies every textbook prediction. Today, the scientific consensus has shifted from comfortably distant to uncertain by orders of magnitude, which is the polite, academic way of saying that it could happen tomorrow morning. Stay with me, because today I am going to show you exactly what the warning will look like when it finally comes. Let's get into the briefing. Imagine you are walking down Fifth Avenue in New York City at sunset. The sun is dropping below the skyline in the west, and the orange glow is doing exactly what an orange glow always does, painting the skyscrapers in warm light and stretching the shadows of the taxis across the asphalt. It feels like a normal evening, a routine end to a busy day. But as you walk, something feels fundamentally wrong. You look down at your feet and realize your shadow is stretching in two different directions at once. You turn east, away from the setting sun, and there it is, blazing through the twilight like a second sun. A brilliant, piercing white star wrapped in a blood-red halo. It is so bright that it hurts to look at directly. It is so powerful that it is casting a second shadow of your body across the pavement. A shadow that is sharp, cold, and red, pointing west, away from the rising intruder. This is not a movie, and it is not a simulation. And the strange thing is that nothing about this scene is implausible anymore. There is a star in our cosmic neighborhood that is actively destabilizing. The timeline we were promised has shattered into pieces, and the only question left for us to answer is when that light finally arrives. The star is Betelgeuse. You know it, most people do, even if they don't realize they are looking at it. It is the bright red point that marks the left shoulder of the constellation Orion the Hunter. To the naked eye, it looks faintly orange, sitting there every winter night like it has been there forever. And for most of recorded human history, Betelgeuse was just background scenery. It was a fixed point, a reliable marker for navigators, a way to set the dates of religious festivals, or just a place to look up at and feel small. The official line, the one that came from every university and every observatory, was that the star was stable for another 100,000 years. Watch and wait, they said. There is no rush, no urgency. The star will go supernova eventually, but eventually meant a span of time longer than human civilization has even existed. That story, the one we were all sold in school, has quietly collapsed in the last 18 months, and almost nobody in the mainstream media is talking about it. To understand why we are out of time, you have to go back to the autumn of 2019. This is the moment everything changed, even if the world didn't realize it yet. Between October 2019 and February 2020, Betelgeuse did something it had never done in the history of modern astronomy. It dimmed. And it didn't just flicker, it plummeted. The star's apparent brightness dropped from its normal range all the way down to magnitude 1.6. It lost roughly 60% of its visible light output. To anyone looking up at Orion that winter, the constellation looked broken. The Hunter's shoulder had gone faint, as if the life was draining out of it. Astronomers called it the Great Dimming, and for the first few months, nobody had a clean explanation. Two competing theories emerged from the panic. The first was the dust hypothesis, the idea that Betelgeuse had recently coughed up some material from its outer layers, and that material had condensed into a cloud of soot and silicate dust, blocking our view like a cosmic fog. The star was fine, they said. The dust was just in the way. The second theory was the cool spot hypothesis, which suggested that a massive convective downwelling on the southern hemisphere of the star had created a region of significantly cooler plasma, and that cooler region was simply radiating less light. Two different explanations, two different physical pictures. For about a year and a half, the scientific community leaned toward the dust because it was the most reassuring answer. It meant the star wasn't dying, it was just sneezing. But then the reanalysis started, and this is where the story gets uncomfortable, because the reanalysis is what no one is putting on the front page of the news. When astronomers went back through the high-resolution spectroscopic data and ran the interferometric measurements through better models, they found something the dust hypothesis could not explain. The surface temperature of Betelgeuse itself had dropped, not by a tiny statistical wobble, but by nearly 200 Kelvin across the integrated photosphere. That is a real structural cooling event. Dust does not cool a star. Dust just stands in front of it. If the temperature itself dropped, then something inside the star, something deep in the engine room, was failing. The current best supported model is a hybrid, and it is far more terrifying than a simple dust cloud. A large convective downflow lowered the surface temperature, and that cooler patch then enabled the local condensation of dust. The dust was real, but it wasn't the cause, it was the consequence. The cause was a real surface cooling event, and what triggered that cooling event is the part nobody had a good answer to until they started looking at Betelgeuse in a way they had never looked at it before. That is when they found Saguara. Stay with me here, because this is the moment the timeline shatters. Astronomers working independently on different telescopes in different countries started finding the same anomaly, a small, hot stellar object hidden in Betelgeuse's glare. It is roughly 1 to 1.5 times the mass of our Sun, hot enough to be picked up in ultraviolet spectroscopy, and massive enough to leave a fingerprint in the radial velocity data. It is orbiting Betelgeuse on a period of approximately 5.78 years, a pulsation that nobody had ever been able to explain until now. They called this companion star Saguara, and here is the part that should make your skin go cold. Saguara's orbit is so tight that at its closest approach, it doesn't just pass beside Betelgeuse, it plunges straight through the supergiant's outer atmosphere. Every 5.78 years, this companion star drives directly into Betelgeuse like a wrecking ball swinging through fog. It stirs the plasma, it rips convective cells loose, and it drags material out behind it in a massive, turbulent wake. The great dimming of 2020 happened right after Saguara's most recent close approach. The companion star plunged through, tore a piece of the southern hemisphere free, and that structure expanded, cooled, and condensed into the dust cloud that blocked our view. It wasn't a routine stellar burp. Betelgeuse is being actively perturbed, actively murdered, by a star we didn't even know existed 2 years ago. The question is, what happens next? Because if Saguara is doing this every single time it passes through, then every 6 years, Betelgeuse is shedding more mass, losing more of the radiation pressure that holds its envelope up against gravity, and inching closer to the moment its core finally collapses. The next passage is happening right now, in May of 2026. If the wake forms again, if the dust condenses again, the question stops being how long we have left. The question becomes whether the explosion has already happened, and the news is simply still on its way. We are watching a ghost. Betelgeuse is 640 light-years away, and that means every photon hitting our telescopes today left that star 6 centuries ago. The light we see tonight departed in the year 1386 during the Middle Ages. The great dimming we saw in 2019 actually happened in the 1370s. We are sitting on the receiving end of a 600-year-old recording playing on cosmic delay. If the star collapsed yesterday, we wouldn't know it for another 600 years. We are stuck waiting. But as you are about to see, there is one tiny exception to that rule. A strange, physics-heavy warning that will be the only sign humanity ever gets that the end has arrived. Strap in. We are moving away from the history of the dimming and entering the physics of the invisible wave. We are about to look at the neutrinos that are already screaming toward Earth, and the system designed to tell us when the giant finally hits zero. Welcome to Section 2, the 600-year ghost and the neutrino alert. Betelgeuse is approximately 640 light-years away from Earth. Some of the recent reanalyses of the parallax data push the number out closer to 700 light-years, but 640 remains the working anchor for our mission briefing. To understand the psychological vertigo of this distance, you have to sit with it for a second. Every single photon hitting our telescopes today, every bit of red light you see in the shoulder of Orion tonight, left that star roughly 6 centuries ago. The light we are observing right now, on this very day in 2026, departed from Betelgeuse in the year 1386. Think about the world as it was then. In 1386, the Black Death had ravaged Europe only a generation earlier. Geoffrey Chaucer was in the middle of writing the Canterbury Tales. The Ming dynasty in China was barely 20 years old. Tamerlane was conquering Central Asia. Nobody on Earth knew that Betelgeuse existed in the way we know it now. Nobody had a telescope. Nobody had spectroscopy. Nobody had any concept of stellar nucleosynthesis or the violent mechanics of a core collapse. The light you see tonight was emitted by a star that had been burning for millions of years before any human being ever gave it a name. This creates a reality that astronomers do not love being asked about at parties. What does it even mean to ask if Betelgeuse is alive? The honest answer is that the present tense applied to anything at this distance is a polite fiction. We are watching a ghost. We are the recipients of a 600-year-old recording playing on a cosmic delay. Because the information traveling toward us is locked to the speed of light, the ultimate speed limit of the universe, we have absolutely no way to peek ahead. We are trapped in a chronological cage. For all we know, the neutron star at the center of the supernova remnant already exists. It could be sitting there right now in the constellation Orion, spinning at hundreds of revolutions per second, blasting jets of lethal radiation out into the void, and we simply haven't gotten the news yet. The mail is in transit, and it has been traveling through the dark since the Middle Ages. This is the cruel part of cosmology that the textbooks usually gloss over. They compress unimaginable spans of time into present-tense statements for the convenience of our species. We are short-lived creatures. We need a stable picture of the cosmos to organize our lives around, but the cosmos itself is not stable. It is just slow. Stars die, they destabilize, they get torn apart by binary companions like Suwara that we are only just beginning to detect. And every one of those events ripples outward at the speed of light, arriving at our door centuries late. We are reading old mail, and the correspondence we are reading right now contains in its margins a terrifying warning, a warning that the star in the hunter's shoulder is not what it used to be. The 100,000-year timeline we were promised was an artifact of our own ignorance, a result of treating the star as an isolated object when it was actually locked in a lethal dance with a hidden companion. But there is a tiny, physics-heavy exception to this rule of cosmic delay. There is one way the universe allows us to cheat the light-speed barrier, and it is going to be the only warning humanity ever gets that the explosion has actually happened. To understand it, you have to look at the iron wall of nuclear physics. When a massive star like Betelgeuse runs out of fuel, the process does not end gracefully. In its final stage, the core is composed mostly of iron and nickel. This is the dead end. Iron does not give up energy when it fuses, it absorbs it. The moment the core hits a critical mass of iron, the radiation pressure that has been fighting gravity for millions of years simply vanishes. In less than a second, an Earth-sized mass of iron falls inward, slamming into a newly formed neutron star at the center. The rebound from that impact sends a shockwave outward through the star's layers, but the very first things to escape are not the shockwave and not the light. They are neutrinos. These are ghostly, antisocial particles with almost no mass and almost no interaction with normal matter. Neutrinos pour out of the collapsing core in numbers so enormous the human mind cannot hold the figure. The total energy in a neutrino burst from a core-collapsed supernova is roughly 100 times more than the energy released as visible light. Because they barely interact with the dense matter of the star, they slip through the outer layers instantly, while the photons, the light, are still fighting their way through the plasma. This gives us a window, a small, strange, extraordinary window of time. The neutrinos will arrive at Earth somewhere between 2 and 48 hours before the visible light catches up. They are screaming toward us right now, carrying the news of a death that happened 6 centuries ago. And when they get here, they will hit our detectors, massive tanks of purified water and sensors buried kilometers underground in Japan, Italy, and the South Pole. These instruments are shielded by rock and ice from every other source of radiation, waiting for the one signal that matters. Normally, these detectors register only a few background events per day. But when Betelgeuse goes, they will register tens of thousands of hits in 10 seconds. It will be a flood of information that cannot be suppressed or ignored. This is where the Supernova Early Warning System, or SNEWS, comes into play. It is an automated network designed to do one thing. The moment 2 or more detectors on different continents see a coincident neutrino burst, SNEWS issues a global alert. It cannot be stopped by any government, it cannot be classified. The data is held jointly by academic institutions across the world. When that alert goes out, the world will know within minutes that Betelgeuse has detonated. And then we will have a few hours, perhaps a day, to wait. A small, brittle window of human anticipation where we know a star is dead, but we are still waiting for the sky to change. Imagine that morning. Imagine waking up to a notification that the shoulder of Orion is gone. Schools will cancel classes, observatories will open their doors, and every lens on the planet will be pointed east. We will be a single audience of 8 billion people, standing on rooftops and in backyards, waiting for the photons to arrive. The last unambiguous galactic supernova visible to the naked eye was in 1604, observed by Johannes Kepler. Nobody alive today has ever experienced an event of this scale. We are about to witness a type of light that no one in modern history has ever seen. It will be gradual at first, a steady brightening that rivals Venus within an hour. Within 12 hours, it will surpass Jupiter, and then it will hit its peak, a piercing, unreasonable pinprick of light that will cast hard shadows at midnight and be visible in broad daylight. This is the second sun scenario, and it is no longer a theoretical exercise. The destabilization we are seeing in the 2026 data confirms that the star is in its final phase. We have been watching a recording of a dying king, and the final scene is about to play out. The red shadow that will stretch across your pavement at midnight is a physical prediction of the hydrogen recombination in the star's expanding envelope. It will be a brilliant white core wrapped in red wings. And the most chilling part is that we cannot peek ahead to see if the recording has already ended. We are receivers of a 600-year-old message, and the ink is finally starting to burn. Stay with me, because in the next part of this briefing, we are going to look at the day the sun rises twice. We are going to look at the radiation panic, the ozone crisis, and the reality of living under a second sun for 3 months. The giant is awake, Commander. The clock is at 0, and the neutrinos might already be passing through your body as you watch this. Welcome to Section 3, the night the sun rose twice. The neutrino sensors have done their job. The SNEWS alert has been issued, and the world has spent its small, brittle window of anticipation looking toward the eastern horizon. Now, the photons finally arrive. It does not happen as a sudden, blinding flashbulb moment that illuminates the entire sky in a microsecond. Instead, it is a gradual, relentless climb into the unreasonable. Within the first hour of the light's arrival, Betelgeuse rivals Venus, the brightest planet in our sky and a familiar beacon for anyone who has ever looked up. But it doesn't stop there. Over the next 12 to 24 hours, the curve continues to skyrocket. It surpasses Jupiter. It surpasses every other stellar object in the night sky, and then it hits its peak. According to our most refined models, the peak brightness will sit somewhere between apparent magnitude and... To understand the magnitude of this event, you have to look at your primary celestial reference, the moon. Half moon shines at roughly magnitude -10. A full moon, at its most brilliant, hits magnitude. Betelgeuse at its peak will be brighter than a half-moon and will approach the luminosity of a full moon. But there is a crucial difference that will mess with your perception and trigger a sense of deep biological unease. The moon spreads its light across half a degree of the sky. It is a soft, reflected glow. Betelgeuse, however, will be a single, piercing pinprick on the celestial sphere. All of that power, all of that magnitude, will be focused into one point of light. It will not look natural. It will look like a hole has been punched in the fabric of space, and the light from a much more violent universe is bleeding through. You will be able to read a book by this light at midnight, not as a metaphor, but as a literal physical fact. Imagine stepping out into your backyard at midnight on a moonless, clear night during this peak. You will see hard shadows, sharp, defined, and eerily still. If you hold up your hand, you will see two shadows on the ground, one from whatever street light or porch light is nearby, and one from Betelgeuse. And the Betelgeuse shadow will have a faint, unmistakable reddish tint. This is the red shadow visual that the mission brief warned you about. It is a physical prediction of the supernova's photospheric expansion. The light is produced by hydrogen recombination, creating a brilliant, diamond-white core wrapped in red wings of plasma. The scene is not theatrical. It is the cold reality of a Type II supernova occurring in our immediate neighborhood. For the first time in 400 years, humanity will be cast in the light of a dying god. But the most shocking part of this briefing is that the night is only half the story. This is the part that astronauts and astrophysicists emphasize when they talk about a Betelgeuse event. It will be visible in broad daylight. A magnitude point source against a sunlit blue sky is not subtle. You will walk outside at noon, look toward the eastern sky where Orion would be if the atmosphere weren't glowing, and there will be a star hanging in the blue. It will be smaller than the sun, and certainly fainter, but it will be unmistakable. A crisp point of red and white light holding its position while the yellow sun blazes in the south. Two suns in the sky at once, both visible to the naked eye, both casting their own distinct light onto the world below. It will be the most significant psychological event in human history, an atmospheric disruption that no one alive is prepared for. Analyze the inevitable wave of panic. It will start almost immediately after the neutrino alert, and it will be whipped up by those who have not done the math. You will hear the questions echoing across social media and news channels. Is the radiation going to kill us? Will the gamma ray burst strip the ozone layer? Is the cosmic ray flux going to trigger a mass extinction? Are the neutrinos dangerous? Let me say this very clearly for the record. At 640 light-years, Betelgeuse is too far away to threaten the biosphere of the Earth. High-energy radiation obeys the inverse square law of distance. By the time those gamma rays reach our upper atmosphere, they have been diluted by such an enormous volume of empty space that they pose no threat to life on the surface. Our atmosphere is a fortress that has stood for billions of years, and it will hold. This is a spectacle, Commander, not an execution. If Betelgeuse were 50 light-years away, we would be in a fight for our lives. The radiation would indeed strip the ozone and leave us vulnerable to the sun's UV rays. But at 640 light-years, distance is our absolute shield. The neutrinos will pass through your body by the trillions every second, but they will do so without noticing you exist. That is the nature of the ghost particle. The visible light is intense, yes, but it is just light. We have lived under the fury of our own sun for our entire evolutionary history. A pinprick of light in the sky, even one this bright, is not going to harm a single blade of grass. You can stop holding your breath about the end of the world. What you cannot stop holding your breath about is the sheer duration of this event. Because a Type II supernova is not a flashbulb, it is a slow-burn disaster. This is the plateau phase. Unlike some supernovae that peak and fade in a matter of days, Betelgeuse will burn at its maximum brightness for approximately 80 to 100 days. This happens because the expanding hydrogen envelope of the dying star is recombining, releasing energy at a roughly constant rate as it cools. For 3 entire months, the sky will be broken. Every night when the sun sets, the supernova will rise, brilliant, unwavering, and permanent in a way that nothing in the night sky has ever been in human memory. Your evening routine by the second month will involve walking outside and looking east, because the human mind cannot look away from a second sun. The world will not stop staring. The psychological impact of this will be something we have never measured. For our entire evolutionary history, the stars have been the only fixed thing in our environment. The sun moves, the moon phases, the clouds come and go, but the stars are constant. And then one of the most familiar ones, the red point in the shoulder of the hunter, becomes something else entirely, a blazing intruder that stays for a season. The closest analogues we have are the supernovae of 1006 and 1054, which produced the Crab Nebula. Those events were documented by Chinese, Arab, and Native American astronomers in fascinating detail. They were seen as omens, as shifts in religious cosmology, and were absorbed into the cultural memory of every society that watched them. But a modern Betelgeuse event, with 8 billion people connected by instant communication, will be something else entirely. We will not just watch it, we will consume it. We will photograph it, share it, argue about it, and eventually we will have to adapt to it. The light will affect the way the world looks at all hours. Even when the supernova is below the horizon, the mountains and the clouds will glow faintly with reflected light from a source that refuses to go away. The whole psychological texture of life on Earth will shift for a season. And then slowly, after those 3 months, the light curve will finally start to drop. Magnitude -12 will become, then -8, then -5. Within 6 months, it will slip below zero, becoming fainter than the brightest stars in the normal night sky. Within a year, you will need binoculars or a telescope to even find it. The supernova will fade, leaving behind a thin, expanding cloud of gas, a wound in the interstellar medium that will grow for tens of thousands of years. But as the light fades, the science begins. Every observatory on Earth and in orbit will have been recording every possible wavelength. We will have the chemical fingerprints of every element produced in that nuclear furnace, the iron, the cobalt, the nickel, and the trace amounts of heavier elements that get forged in the brief, brutal rebound of a core collapse. We will have the spectra of an exploding star at a distance of 640 light-years, with modern instruments for the first time in human history. This data will rewrite half a dozen subfields of astrophysics. Every textbook on stellar nucleosynthesis will need a new chapter. Every model of supernova light curves will be tested against actual data that isn't just a smudge in a distant galaxy. It will be a once-in-a-thousand generations gift to the people whose careers were built on guessing what this looks like. Stay with me, because as we look at the aftermath of the flash, a more disturbing question begins to emerge. If we got the timeline for Betelgeuse so wrong, if the isolated star model failed us, then what does that mean for the rest of our cosmic neighborhood? Are we looking at a wounded hunter in Orion, or are we looking at the first of many dominoes to fall? We are moving away from the light and into the neighbor threat. We are going to look at Antares, Rigel, and the other giants that might be hiding their own Suwara companions in the dark. The giant is gone, Commander. Orion is broken, and the search for the next one has already begun. Welcome to Section 4, the broken hunter and the neighbor threat. Look at the constellation Orion 1 year after the flash has faded. The year is over, the light has retreated into the binocular-only range, and for the first time in human history, the left shoulder of the hunter is empty. Right now, when you look up, you see the belt, 3 stars in a line, and above them 2 bright markers, Betelgeuse on the left, Bellatrix on the right. But after the supernova, the symmetry is gone. There is only a faint, expanding patch of nebulosity where a star used to be. Children born after this event will learn about Betelgeuse in history class, not astronomy. They will see photographs of what Orion used to look like, the way we look at pictures of vanished cities. They will believe us in the abstract way you believe anything you read about a world that no longer exists. Because by then, Betelgeuse will be a story rather than a star. But let's slow down and look at the telemetry, that should be keeping the planetary defense community awake at night. If the textbook treatment of Betelgeuse was wrong, if the 100,000-year timeline was just an artifact of treating the star as an isolated object, then we have to ask a terrifying question. How many other nearby supergiants are running on the same flawed assumption? How many other massive, evolved stars in our immediate cosmic neighborhood are quietly being torn apart by gravitational interactions we have not detected yet? The isolated evolution model, the foundation of every astronomy degree for 60 years, has just been humiliated by Betelgeuse. We assumed stars aged in silence. We were wrong. They age in violence, often driven by companions they hide in their glare. Access the data for the neighbor candidates. The list is not obscure, and it is closer than we'd like to admit. First, look at Antares. It is the bright red heart of the constellation Scorpius, sitting roughly 550 light-years from Earth. It is a red supergiant similar in many ways to Betelgeuse, but with a slightly higher mass. Then look at the foot of Orion, Rigel. It is a brilliant blue-white supergiant sitting 860 light-years away. Move your gaze to the constellation Cygnus and find Deneb, the star in the tail of the swan, located at approximately 2,600 light-years. And then there are the hypergiants, the true kings of the graveyard. VY Canis Majoris, sitting 3,800 light-years away, and NML Cygni at 5,300. All of these stars are massive, all of them are evolved, and all of them are candidates to go supernova in the geologically near future. Here is the part that should make your skin go cold. As far as we know, none of these neighbors have a confirmed plunging companion like Sawara, but in the world of professional astrophysics, as far as we know is a dangerous phrase. It does not mean we have proven they are alone. It means we have looked at them using the same techniques and assumptions that just got Betelgeuse so wrong. The hidden companion that is currently murdering Betelgeuse was sitting in our data for decades. We had the radial velocity fingerprints. We had the secondary pulsations. We just hadn't figured out how to see them. We treated the star as a single point because it was easier for the math. This means Antares could have a Sawara, Rigel could have one, Deneb could have one. The plunging companion class might not be a cosmic curiosity. It might be the dominant mechanism by which massive stars approach their final detonation. If this is true, the whole field of pre-supernova astronomy has been operating with a systematic blind spot. We have been looking at isolated star models when the actual physical reality involved binary partners that were too faint or too close to detect. We haven't been watching stars die. We've been watching them be executed. Consider the order of death. If the plunging companion mechanism is real, and if it accelerates the late-stage fusion sequence by stripping mass and increasing core compression, then the order in which stars explode might not match the textbooks at all. Betelgeuse is at the top of the most likely list because it is bright and nearby. But if Antares has a hidden destabilizer that is more aggressive than Sawara, then maybe Antares is the next one. Or maybe it's a star we haven't even categorized as unstable yet. The candidate ranking we all grew up with is a model, not a measurement. And that model has just been dismantled. There is no reason to assume the universe is following our schedule. We are sitting on the receiving end of a 600-year-old recording, watching a star do whatever it is doing in slow motion, while its neighbors might already be further along in their death rattle. The broken timeline of the James Webb is now infecting our local star charts. We don't just have a mystery at the edge of the universe, we have a reliability crisis in our own backyard. Analyze the phenomenon that astronomers call supernova imposters. Sometimes a massive star doesn't die in the classical sense. Instead, it undergoes a non-terminal outburst, a massive ejection of material that mimics a supernova for months but leaves the core intact. The most famous example is Eta Carinae. In the 1840s, it underwent its great eruption, becoming the second brightest star in the entire sky. It sustained that brightness for years before fading back into obscurity. The star survived, but it left behind the Homunculus Nebula, two massive lobes of dust and gas that look like a wound in space. Do you understand the implication for Betelgeuse? No one can rule out that what we are seeing is not the core collapse, but the start of an imposter event. If Suarez perturbations strip enough mass from the envelope without triggering the final iron core collapse, the result might not be a supernova. It might be an Eta Carinae-class tantrum. This would be its own kind of historical trauma, a second sun in the sky for a year, a world-altering brightening event that doesn't actually end the star's life. The textbooks would have to be rewritten. Every documentary would have to be reshot, and we would still be sitting here, looking at a wounded star in Orion, waiting for the actual collapse to come at some unknown date. This branches our mission into two terrifying paths. Path 1, the core collapses and the star is gone. Path 2, the star erupts, stays for a year and then remains as a wounded giant, a ticking time bomb that will haunt our descendants for another 1,000 years. In both scenarios, the 100,000-year safety net is gone. The corrected version of our reality says, Betelgeuse is unstable. The timeline is uncertain by orders of magnitude. The immediate next event could be a dimming, an ejection, an imposter outburst, or the final detonation. And we cannot tell which one is coming, because the information is locked behind 640 years of cosmic delay. But as we look at the destabilization of our neighbors, we have to address the things you are going to hear in the comments, the things that the scientific establishment refuses to acknowledge in public. People are starting to ask if all of this is connected. Is the destabilization of Betelgeuse linked to the unusual interstellar objects like Oumuamua? Is it linked to the global fireball surge recorded in 2026? Some theorists are proposing that we are entering an active phase of the universe, a cosmic phase change where stellar deaths and interstellar traffic are increasing. The honest professional answer is that there is no demonstrated physical mechanism that connects a star 600 light-years away to a rock passing through our solar system. The geometries don't match. The timescales don't match. They are separate stories. And this is a real but. We are observing the universe with instruments and at scales we have never used before. James Webb has been running for less than 4 years. Our fireball networks are more sensitive than anything our grandparents had. Our neutrino detectors are picking up signals that would have been missed a decade ago. So here is the final logic of this section. A portion of what looks like an active universe to us is genuinely an active universe, and a portion of it is just better instrumentation revealing activity that was always there. The question of which fraction is which is still open, but pattern recognition is the channel's territory, and the audience knows it. We are a young species watching the cosmos for a few centuries. The fact that we are noticing more strange things now is a warning. It is a warning that the sky is not as fixed as you have been told. The correspondence we are reading from the stars right now contains in its margins a terrifying truth. The timeline has shifted. The stars are not background scenery. They are actors in a drama that is reaching its climax. The neutrino detectors are running tonight. Supergiant and IceCube, SNO+, they are all waiting for the signal that says the giant has hit zero. But as we wait for the neutrinos, a new kind of electronic chatter is filling the web. People are starting to claim that NASA is already hiding the truth, that the explosion has already happened, that the government is prepositioning for an announcement. Strap in, we are moving away from the physics of the stars and into the world of the conspiracy and the science. We are going to look at why the news might be suppressed, how amateur astronomers are the only ones who can't be silenced, and what the slow drip of information tells us about the coming panic. Welcome to Section 5, the Information War and the Neutrino Guard. Initialize the electronic scans. Access the digital chatter logs. To understand the final hurdle of our mission, we must leave the vacuum of space and enter the volatile world of human information. As the news of Betelgeuse's destabilization leaks into the public consciousness, we are witnessing the birth of a new kind of conflict, the information war. There is a particular flavor of conspiracy theory that has been circulating online for years. and the story of Saguaro, the hidden companion star, is currently pouring gasoline on that fire. People are starting to ask the dangerous questions that the establishment hasn't prepared answers for. They are asking why the 100,000-year timeline shifted so quietly. They are asking why there was no global press conference. And they are asking if the explosion has already happened, and the news is being suppressed to prevent a total collapse of the social order. Analyze the first version of the cover-up narrative. It goes like this. NASA and the European Southern Observatory have known for decades that Betelgeuse was on the brink of collapse. The official 100,000-year line was a deliberate calculation designed to keep the public calm while the elite built underground bunkers. This theory points to the 2019 Great Dimming as the moment the secret leaked. They claim the dust cloud explanation was a tactical lie, a reassuring story meant to buy more time while the star was actually undergoing a catastrophic structural failure. Here is the uncomfortable truth that fuels this narrative. The timeline did shift, and it did happen quietly. The collapse of the 100,000-year model didn't happen in a televised address. It happened in professional journal articles with technical titles like The Carbon-Burning Phase of Alpha Orionis. Why? Because there is no central department of supernovas that has the power to suppress data. The information is collected by hundreds of independent teams using dozens of different telescopes, the VLT in Chile, the James Webb in orbit, ALMA in the desert. But more importantly, it is tracked by a global network of amateur astronomers. Thousands of people in backyards with high-end telescopes, uploading data to public databases every single night. You cannot coordinate a cover-up among 10,000 independent observers. The shift happened quietly because science happens quietly, but in a world addicted to instant drama, quiet science looks like a secret cover-up. The second conspiracy is more dramatic. It claims that Betelgeuse has already exploded, that the neutrino burst arrived weeks ago and was suppressed by governments who are now prepositioning assets before an announcement. I do not love debunking this one too aggressively because the actual situation is a little uncomfortable. Betelgeuse could have already exploded. We genuinely cannot know until the photons get here. The light cone of Earth is a one-way street, and we are just receivers at the end of the line. But access the data for the Supernova Early Warning System, SNEWS. This is the neutrino guard that makes suppression impossible. SNEWS is an automated network that connects the world's most sensitive detectors, Super Kamiokande in Japan, IceCube at the South Pole, and SNO Plus in Canada. These facilities are buried under kilometers of rock and ice for one specific reason: to shield them from every other source of radiation in the universe, so that only the ghost particles can pass through. Normally, these detectors register only a few background events per day, but when Betelgeuse's core collapses, these detectors will register tens of thousands of hits in 10 seconds. The SNEWS trigger is automated. The moment two or more detectors on different continents see a coincident burst, an alert is issued to every major observatory and emergency response agency on Earth. There is no human gatekeeper. The data is held jointly by academic institutions. If the neutrinos hit tonight, the world will know within minutes. The fact that no SNEWS alert has been issued is the most concrete evidence that the core has not yet collapsed in our light cone. However, and this is the part that keeps the conspiracy alive, the neutrinos could be arriving tomorrow morning. We are not in control of the timeline. Analyze the Saguaro anomaly. Some claim the companion star is not a star at all, but something more exotic, a primordial black hole or an artificial object. They point to the plunging orbit as a behavior that defies natural physics. The grounded response is that the data fits the profile of an ordinary low-mass companion, but there is a catch. We do not yet have a direct photograph of Saguaro. Betelgeuse is so bright that it effectively blinds our telescopes to the faint light of its killer. We only know Saguaro exists because of its fingerprint in the data, and shadows are where conspiracies grow. We are operating in a regime where the textbook truth has been humiliated, and when the experts are wrong, the public stops trusting the institutions. Consider the final, most unsettling question. Is this destabilization connected to other anomalies? People are looking at the 2026 global fireball surge and unusual interstellar objects and asking if the universe has entered an active phase. Mainstream science says no, the geometries don't match. But think about the better tools paradox. We are noticing more strange things today because we finally have the instruments to see them. James Webb has been running for less than 4 years. Our neutrino detectors are finally hitting peak sensitivity. We are a young species that has just turned on the lights in a dark room. The fact that we see spiders in the corners doesn't mean the spiders just arrived. It means we can finally see them. The hidden companion is ripping the envelope open. The core is reaching the iron wall, and the message from the 14th century is finally reaching the end of its journey. What would you do in the 24 hours between the neutrino alert and the arrival of the light? You will have a day of knowing that the sky is about to change forever, while the world still looks normal. Would you stay home? Would you call your family? In that window, we will all become a single audience, standing in collective anticipation of an event that hasn't happened in our galaxy in 4 centuries. But while the world is arguing about conspiracies and government alerts, the real battle is happening inside the star itself. All the electronic chatter and digital warnings are just echoes of a much more violent reality happening deep in the engine room of the giant. To understand why the neutrinos are coming, we have to look past the light and into the white-hot laboratory where the rules of nuclear fusion are about to hit a mathematical wall. We are about to look at the ash of the universe and the 1-second event that will turn the hunter's shoulder into a ghost. Strap in. We are moving away from the information war and entering the heart of the fire. Welcome to Section 6, the core collapse iron's dead end. Initialize the internal scans. Access the thermodynamic engine room of the giant. To understand why the 100,000-year timeline has failed, you have to look past the roiling surface of Betelgeuse and peer into the heart of the monster. For millions of years, this star has survived on a simple, elegant balance. Gravity, the weight of a quadrillion tons of plasma, is constantly trying to crush the star into a single point. Fighting back is the radiation pressure, the outward force generated by nuclear fusion. For most of its life, Betelgeuse burned hydrogen into helium. Each stage of this stellar ladder happens faster than the last. But today, the 2026 infrared arrays suggest that the star has reached the final, most lethal rung of that ladder. It has started producing iron. Analyze the physics of the iron wall. In the world of nuclear fusion, iron is the ash of the universe. When a star fuses hydrogen or helium, the process releases energy. That energy is the fire that holds the star up. But iron is different. Iron is the mathematical dead end of the periodic table. To fuse iron atoms together doesn't release energy, it consumes it. This is the moment the contract of balance is broken. The moment the first atom of iron is forged in the heart of Betelgeuse, the engine room begins to fail. The star is no longer creating the pressure it needs to survive, it is stealing it. Do you understand the speed of this catastrophe? A star that has lived for 10 million years will meet its end in less than 1 second. Once the iron core reaches the Chandrasekhar limit, about 1.4 times the mass of our Sun, the structure can no longer support itself. The quantum degeneracy pressure that keeps the atoms apart simply snaps. In a fraction of a heartbeat, a core the size of the Earth, weighing more than the entire solar system, collapses inward. It implodes at 25% of the speed of light. Think about that velocity. In the time it takes you to blink, the center of the star has vanished, falling thousands of miles toward its own center. This is the core collapse, and it is the most violent event allowed by the laws of physics. The core collapses until it reaches the density of an atomic nucleus. It becomes a ball of pure neutrons, only 20 kilometers wide, so dense that a single teaspoon of its material would weigh as much as Mount Everest. This is the birth of a neutron star, and it is the trigger for the end of Orion. The crisis of the dead end forces us to look at the shockwave. When the falling outer layers hit that solid ball of neutrons at the center, they don't just stop, they bounce. It is the most powerful rebound in the kainat. A shockwave of pure energy screams outward. But here is the dirty secret of the textbooks. The shockwave isn't strong enough on its own. As it moves through the outer layers, it loses energy and stalls. For a terrifying microsecond, it looks like the star might just swallow itself. But then the neutrinos arrive. In that final second of collapse, the density becomes so extreme that even neutrinos get trapped. They become so numerous that they push the stalled shockwave. They act as a ghost engine, reigniting the explosion from the inside out. NASA researchers call this the neutrino-driven mechanism. Without these invisible ghosts, the star would never explode. It is a paradox. The smallest particles in the universe are the only things powerful enough to tear a supergiant apart. This is why our detectors are so critical. If the neutrinos are hitting our sensors tonight, the core has already bounced. The king is already dead. Analyze the mass bleeding logs. We saw in the 2019 dimming that Betelgeuse was losing mass at an insane rate. The 2026 data shows that the mass loss is internal. The star is vaporizing its own envelope because the iron buildup is causing the outer layers to lose their grip. And here is the connection to Suwara. Every time that companion star plunges through the atmosphere, it acts as a surgical knife, cutting away the mass that the core can no longer hold. Suwara is accelerating the core collapse by stripping the star of its insulation. We are watching an execution, not a natural death. The broken timeline is a result of us ignoring the killer in the room. Think about the nuclear ash left behind. As the shockwave moves through the star, it performs one final miracle, nucleosynthesis. In the seconds of the explosion, the pressure becomes so intense that the star begins to forge elements heavier than iron, gold, silver, platinum, and uranium. Every gram of gold in the world was born in an event exactly like this. But here is the shock. While the explosion creates gold, the core remains a graveyard of iron. If Betelgeuse dies tonight, it will leave behind a neutron star that is the ultimate iron tombstone. The broken timeline tells us that this transformation is imminent. The star's shiver is the sound of the engine failing. We are standing on the edge of the iron dead end, waiting for the collapse that happened 640 years ago. But before the light of that collapse arrives, something else will hit us. A wave that will pass through the Earth and your own body without you even feeling it. But our machines will scream. Strap in, we are moving away from the internal engine and into the ghost storm. We are about to look at the only warning humanity will get that the explosion is no longer a prediction, but a physical reality. Welcome to Section 7, the Ghost Signal Neutrino Dawn. Initialize the Deep Earth monitors. Lock the primary alert system to the subterranean laboratories of the northern and southern hemispheres. To understand why we are no longer guessing about the end of Betelgeuse, you have to look at the only messenger in the universe that can outrun the news of its own destruction. For centuries, we believed that the speed of light was the only speed that mattered. We assumed that when a star died, the flash of light was the first signal we would receive. But the mission briefing has shifted. As of 2026, we know that light is slow. Light is sluggish. It has to fight its way through the dense, roiling plasma of a star's outer layers, a process that can take hours or even days. But there is another particle, a ghostly intruder that doesn't care about the star's flesh. This is the neutrino, and it is the sound of the universe's starting gun. Analyze the anatomy of the invisible wave. In the final second of the core collapse we discussed in the previous section, the density at the center of Betelgeuse becomes so extreme that it creates an environment unlike anything on Earth. As the Earth-sized iron core implodes into a 20-kilometer ball, it releases a flood of neutrinos so vast that it accounts for 99% of the explosion's total energy. These particles are antisocial. They have almost no mass, and they do not interact with normal matter through the electromagnetic force. While the shockwave of the explosion is still struggling to break through the star's surface, the neutrinos simply slide through the quadrillions of tons of gas like it isn't even there. They leave the star at nearly the speed of light, gaining a massive head start on the photons. Do you understand the psychological vertigo of this signal? As you sit here right now, trillions of neutrinos from distant stars are passing through your eyes, your brain, and the very floor beneath you. You cannot feel them and you cannot see them. But when Betelgeuse hits zero, this trickle will turn into a ghost storm. A wave of energy, carrying the news of a death that happened 640 years ago, will wash over the Earth. It will pass through the atmosphere, through the oceans, and through the core of our planet without slowing down by a single fraction of a millimeter. But it won't pass through our detectors unnoticed. We have built temples of science in the most isolated places on the planet specifically to catch these ghosts. Access the logs for Supernova in Japan and the IceCube Observatory at the South Pole. To catch a neutrino, you have to hide from the rest of the universe. Supernova is a tank containing 50,000 tons of ultra-pure water, buried a kilometer underground in a zinc mine to shield it from cosmic rays. IceCube is a cubic kilometer of ancient, crystal-clear ice at the South Pole, riddled with thousands of optical sensors. Normally, these detectors are silent, registering only the faint, rhythmic drip of background solar neutrinos. But when the shoulder of Orion breaks, these facilities will scream. They will register tens of thousands of flashes, tiny blue sparks called Cherenkov radiation, in a matter of 10 seconds. This is the neutrino dawn, the only warning humanity will ever get. The crisis of the first signal forces us to look at the SNEWS protocol, the supernova early warning system. In the world of international politics, news is often filtered, delayed, or classified, but the physics of a supernova refuses to be managed. SNEWS is an automated network that links the world's neutrino detectors into a single global alarm. It was designed with a no-human-in-the-loop architecture. The moment two or more detectors on different continents record a coincident burst of neutrinos, the system automatically triggers a global alert. Think about the implications of this institutional secret formula. There is no government agency, no space council, and no elite bunker that can suppress the news. The data is held by academic consortia across the planet. If the detectors light up at 3:00 a.m., the alert is sent to every major observatory, every amateur astronomy club, and every emergency broadcast system on the planet within minutes. We will wake up to the knowledge that a star is dead, but the sky will still look exactly the same. The hunter's shoulder will still be red, the world will still be quiet. We will be living in a brittle window of time, a gap of 2 to 48 hours where we know the catastrophe has happened, but the evidence hasn't arrived yet. Analyze the psychological texture of that waiting room. Imagine the morning the alert goes out. Social media will not just be flooded, it will collapse under the weight of 8 billion people asking the same question. Schools will close their doors. People will stop their cars in the middle of highways. We will become a single global audience standing in collective anticipation of an event that hasn't happened in our galaxy since the year 1604. This is the Kepler gap. For 422 years, we have been blind. No human being alive has ever experienced a nearby supernova since the invention of the telescope, the camera, or the internet. We are the generation that will break the silence. Here is the high-stakes reality of the mission. In that 24-hour window, the world will undergo a transformation. Scientists will go on television to explain that we are safe, that the 640 light-years of distance act as our shield, but the public will only half believe them. A thing that bright, a thing that violent, doesn't feel like it doesn't matter. People will look for omens. Religious leaders will interpret the end of Orion through ancient frameworks. Doomsday cults will declare the 0 hour, and through all the noise, the astronomers will be the most terrified of all, because they know that even with all our math, we don't truly know what the light curve will look like. We have never seen a red supergiant collapse from this close. We are guessing, and the universe is about to show us the answer. Consider the information delay we discussed in Section 2. The neutrinos tell us that the core has collapsed. They tell us that the neutron star has been born, but they don't tell us if the star underwent a full supernova or an imposter event. We have to wait for the photons, the light, to fight their way through the star's outer envelope. This is the final act of the cosmic correspondence. The mail has been delivered to our neutrino detectors, but the photo inside the envelope is still being developed by the star itself. We are watching the slowest, most intense reveal in history. Access the final simulation for the first light arrival. When the shockwave finally breaks the surface of Betelgeuse, the star will not just blink, it will swell. Within an hour, it will rival the brightness of Venus. Within 12 hours, it will cast shadows. And this is the sensory trigger that will haunt your dreams. You will be able to stand in your backyard at midnight and see red shadows. The light of the supernova, dominated by the recombination of hydrogen, will be a brilliant white center wrapped in a deep, bloody red halo. The broken timeline has led us to this moment. We ignored the shivers of 2019. We dismissed the Sawara perturbations as noise. We clung to the 100,000-year safety blanket, but the neutrinos don't lie. They are the objective truth of the universe. If they are hitting the ice at the South Pole tonight, then the shoulder of Orion is already a memory. The recording has ended. The live show is about to begin. We are moving away from the invisible wave and into the arrival. We are about to look at the day the night vanished. We are going to look at why the hunter will lose his arm forever, and why the second sun will stay in our sky for 3 entire months. The giant is awake, Commander. The clock is at 0, and the first photon is already crossing the orbit of Pluto. Strap in, we are leaving the underground labs and heading to the rooftops. We are about to witness the most violent event in human history. Welcome to Section 8, 0 hour the second sun rises. Initialize the optical sensors. Clear the global broadcast channels. The waiting is over. The brittle window, those 24 to 48 hours of agonizing anticipation after the neutrino alert, has finally slammed shut. For a day and a night, the world was a powder keg of nerves, looking at a sky that refused to change. But the photons, the messengers of fire that were delayed by the star's own dense plasma, have finally fought their way to the surface. They have crossed the 640 light-year void, bypassed the orbit of Pluto, and are now hitting the nitrogen and oxygen of our upper atmosphere. The transition from prediction to presence is about to rewrite the history of the human eye. Think back to the Fifth Avenue hook we discussed at the start of this briefing. It is a normal evening. The sun is dipping below the skyscrapers and the streetlights are beginning to flicker to life. The news has been screaming on every screen for a day, but as you look up, the constellation Orion still looks the same, a faint red point in the hunter's shoulder. And then it happens. It doesn't start with a bang you can hear. Space is a vacuum and the giant dies in silence. It starts with a blooming. The red point begins to expand, not in physical size, but in raw, piercing intensity. Within minutes, it is no longer a star. It is a glare. It surpasses the brightness of Sirius, then the brilliance of Jupiter, then Venus. By the time the first hour of the arrival is over, the sky has a new master. Analyze the physics of the shock breakout. This is the moment the internal supernova shockwave, driven by the neutrino wind, finally punches through the star's photosphere. The surface temperature of Betelgeuse, which was a cool 3,500 Kelvin, suddenly skyrockets to over 100,000 Kelvin in a matter of seconds. This is the most violent temperature spike a single object can experience. The star is effectively turning inside out. The light hitting your eyes is the result of trillions of tons of radioactive nickel and cobalt being forged in real time. This isn't just a light. It is the visual signature of a nuclear furnace that has lost its lid. Every photon is a bullet of information, telling the story of a core that collapsed 640 years ago. Do you understand the scale of the shadow shift? As the brightness climbs toward magnitude and eventually -12, the world undergoes a sensory transformation that our biology is not programmed to handle. Imagine standing in a park at midnight on what should be a moonless night. Usually the darkness is a blanket, a protective layer of anonymity. But now the supernova is so powerful that it is casting hard shadows. Look down at your feet. You will see a shadow so sharp and defined that you could count your own fingers on the pavement. But the color, this is the dread factor, is fundamentally wrong. Because the supernova is a type 2p, it is dominated by hydrogen recombination. The core of the light is a piercing electric white, but the edges are a deep, bruised crimson. Your shadow will not be black, it will be a dark, bloody red. Let's talk about the sensory impact of this new light. Walk inside your house. Turn off every lamp, every LED, every screen. Usually your room would be an abyss. But now the light from a dying star 600 light years away is pouring through your window with the intensity of a stadium floodlight. You can sit on your bed and read a book by the light of a cosmic execution. You can see the dust motes dancing in a beam of light that originated in the 14th century. The sheer presence of the star will feel invasive. It is a light that shouldn't be there, a light that violates the natural order of day and night. The crisis of the second sun reaches its peak during the daytime. This is the scene that will break the collective psyche of the planet. You walk out of your office at noon. The yellow sun is high in the south, blazing with its familiar, life-giving warmth. But as you turn your head to the east or west, there it is, hanging in the blue sky like a diamond-tipped needle. For the first time in recorded history, the blue of the atmosphere is being illuminated from two different directions. The shadows of trees and buildings are doubling, stretching in conflicting geometries. One shadow is warm, yellowish, and diffuse. The other is cold, sharp, and reddish. It will feel like the Earth has been transported to a binary star system, a world with two masters. Analyze the global response. Every camera, every smartphone, and every telescope on the planet is pointed at that one spot in Orion. The internet, which was built for cat videos and political arguments, is now a single synchronized stream of raw celestial data. But as we watch, the scientific panic begins to set in, because the light curve is not following the neat, symmetrical lines of our computer models. The Suara effect, that hidden companion star, is creating flickers in the supernova's expansion. The companion star is still there, now trapped inside the expanding shell of the explosion. It is stirring the radioactive guts of Betelgeuse, causing the brightness to pulse like a dying heart. Amateur astronomers will be the first to notice that the star isn't just bright, it's vibrating. Consider the psychological trauma of a broken sky. For our entire evolutionary history, the stars have been the only fixed thing in our environment. Governments fall, cities crumble, and climates change, but the stars are constant. And then one of the great pillars of the heavens, the red point in the shoulder of the hunter, becomes a blazing intruder. The realization will hit: if the most famous star in the sky can turn into a monster overnight, what else have we misunderstood? The sense of cosmic safety that we felt while looking at the 100,000-year timeline will evaporate. We will realize that we are living on a small, fragile rock, surrounded by giants that can wake up at any moment. But as the days turn into weeks, the novelty will fade into a persistent haunting. This is not a flashbulb event that disappears after a few nights. Because of the plateau phase, the supernova will stay at peak brightness for nearly 3 months. Think about that. 90 days of a sky that never gets dark. 90 days of red shadows. 90 days of two suns. The psychological impact of perpetual twilight will begin to affect human productivity and named sleep. The world will feel like it is in a dream state. A long, drawn-out fever dream where the sky is broken and the hunter is bleeding. Analyze the biological chaos. Birds will stop singing, confused by a night that never truly arrives. Nocturnal predators like owls and leopards will find their hunting grounds illuminated by a light they don't understand. Samandari Makluk marine life, like sea turtles that navigate by the stars, will be led astray, beaching themselves in record numbers because the shoulder of Orion is now 10,000 times brighter than it should be. The Earth's biosphere, which has spent millions of years fine-tuning its rhythm to the rotation of the planet and the cycle of the moon, will be thrown into a state of evolutionary shock. Think about the religious and cultural upheaval. In every corner of the globe, people will look at the second sun and see something different. For some, it will be a sign of divine judgment. For others, it will be the eye of God. For the cynical, it will be a distraction from the problems of Earth. But for everyone, it will be an unavoidable reality. You cannot look away from a supernova. You cannot unsubscribe from the end of a star. It will be the first truly universal experience in human history. 8 billion people, from the skyscrapers of Manhattan to the villages of the Himalayas, all bathed in the same ghostly red light. The broken timeline has led us to this moment. We ignored the shivers of 2019. We dismissed the Suwara perturbations as noise. We clung to the 100,000-year safety blanket. But as the photons hit the Earth, the lie is exposed. The giant was never stable. It was always a time bomb, and the timer hit 640 years ago. We are simply the generation that happened to be standing in the path of the light. We are the ones who have to explain to our children why the sky looks different than it did in their storybooks. But while the public is staring at the beauty and the Hebat awe of the light, the mission briefing moves into the long fade. Because after the 3 months of fire, the giant begins to cool. The plateau ends and the light curve begins its long, slow descent into the void. This is where the true loss begins. We are about to witness the permanent alteration of the night sky. The hunter is about to lose his shoulder, and he is never getting it back. The giant is no longer a ghost. The recording has finished playing, and we are now living in the live broadcast of a catastrophe. Orion's shoulder is on fire, and the smoke, a nebula of radioactive dust, is already beginning to spread. But while we stare at the light, the scientists are looking at something else. They are looking at the void that will follow, because after the fire comes the erasure. Strap in, we are moving away from the arrival and into the plateau phase. We are about to look at the reality of a world that has forgotten how to be dark. We are going to examine the 90 days of fire and the cooling of a king. Welcome to Section 9, the Plateau Phase, 3 months of fire. Initialize the long-term observation logs. Set the temporal scale to months. We have passed the initial shock of the 0 hour. The world has witnessed the arrival of the light, the shock breakout that turned the shoulder of Orion into a piercing diamond. But now we enter the most grueling part of the cosmic briefing, the plateau. In most Hollywood depictions of cosmic events, there is a flash and then a fade. But the physics of a type IIP supernova like Betelgeuse is not interested in cinematic brevity. It is a slow, agonizing process of recombination. For the next 90 to 100 days, the sky will refuse to return to normal. Humanity is about to learn what it means to live under the gaze of a dying king that refuses to leave the throne. Analyze the hydrogen recombination mechanism. This is the scientific reason for the plateau. When Betelgeuse exploded, it didn't just release light, it threw out a massive, opaque shell of hydrogen gas, its own former atmosphere. As this shell expands into the vacuum of space, it begins to cool. Once the temperature drops to around 5,000 Kelvin, the ionized hydrogen atoms begin to capture electrons again, a process called recombination. This release of energy acts as a buffer. It keeps the star's luminosity at a nearly constant, terrifying level. While the core is already cooling into a neutron star, the outer shell is essentially leaking energy at a steady rate. This is the plateau phase, and it is the reason the second sun will stay in our sky for an entire season. Do you understand the psychological fatigue of month 2? In the first 2 weeks, the world is in a state of collective awe. People throw supernova parties. The internet is a 24/7 stream of high-resolution images. But by day 45, the novelty begins to rot into a deep biological unease. The second sun becomes a persistent intruder. You wake up for the 45th day in a row and see the same piercing red glare hanging in the sky. It begins to feel like a celestial stalker, a light that you cannot switch off and a presence you cannot ignore. The human mind is evolved to seek the comfort of the dark, but the dark has been exiled. Think about the circadian collapse. Our bodies are governed by the melatonin cycle, a delicate hormonal balance triggered by the onset of darkness. But with Betelgeuse shining at magnitude -12, the dark is a polite fiction. Even when the supernova is on the other side of the planet, the upper atmosphere scatters its light, creating a permanent deep twilight. People will report chronic insomnia, heightened anxiety, and a sense of temporal disorientation. The world will feel like it is living in a permanent midnight sun of the Arctic, but without the cold. The red shadows we discussed in the arrival section will become a permanent feature of our architecture. Every street, every park, and every bedroom will be stained with the bruised, crimson light of a star's death throes. Analyze the biological toll on the planet's non-human inhabitants. This is the section of the briefing that environmental scientists fear the most. Migration patterns, which have been fine-tuned over millions of years, will shatter. Millions of songbirds, which navigate by the stars and the sunset, will become trapped in mid-flight, unable to find their bearings. They will fly until they drop from exhaustion. In the oceans, the diel vertical migration, the largest movement of biomass on Earth, where deep-sea creatures rise to the surface at night, will be thrown into chaos. The night they wait for never truly arrives. The food chain of the entire planet will experience a shock pulse. We are witnessing a biological mass confusion event caused by a star 600 light-years away. Consider the color shift of the plateau. In the beginning, the supernova was a brilliant, electric white. But as we move into month 2 and 3, the recombination zone moves deeper into the star's envelope. The light begins to redden. The second sun transforms from a diamond white needle into a blood-orange orb. The sky at noon will look like a bruised painting. The interaction between the yellow sun and the deep orange supernova will create a color palette that no human being has ever seen before. The atmosphere will feel heavy, stained by the chemistry of an exploding giant. Access the Saguaro disturbance logs. Even during the plateau, the light is not perfectly steady. The hidden companion, the wrecking ball star Saguaro, is now engulfed in the expanding debris of the explosion. As it orbits the center of the blast, it creates gravity waves and density spikes in the plasma. This causes the plateau to flicker. Every few days, the brightness will pulse, dropping slightly and then surging back. To the people on Earth, it will look like the star is breathing or struggling. This stellar heartbeat will feed the doomsday cults and the conspiracy theorists. They will claim the star is sentient or that it is a signal. The reality is much colder. It is just the physics of a binary execution playing out in its final stages. Think about the economic and social disruption. Productivity will plummet as the world's sleep cycles fail. The energy grid will face unusual loads as people keep their lights on to drown out the red shadows or run air conditioning to combat the psychological heat of the light. But more than the economy, it is the human spirit that will be tested. For 3 months, we will be reminded of our irrelevance. We will look up and see a physical manifestation of cosmic violence that we cannot control, predict, or stop. The ego of the human race, which believes it has mastered the planet, will be humbled by a single point of light. Analyze the atmospheric chemistry during the plateau. While the 640 light-years protect us from a lethal dose of radiation, the visible light flux and the soft X-rays from the shock breakout will have subtle effects. We might see persistent auroras, glows in the sky that stay for weeks, even at low latitudes. The upper atmosphere will be excited by the constant bombardment of photons. The very air we breathe will be slightly altered in its electrical charge. It won't kill us, but it will make the world feel electric, tense, and unnatural. By the end of the third month, the hydrogen recombination will finally reach the inner layers of the star. The plateau will begin to drop. The cliff of the light curve is approaching. This is the moment when the second sun finally begins to fade, but do not mistake this for a return to normalcy. The fading is just the start of the void. As the light retreats, it will reveal a sky that has been permanently altered. The hunter's shoulder is not coming back. Think about the final night of the plateau. Imagine the moment when the supernova finally drops below the brightness of the moon, then below the brightness of Venus. For the first time in 90 days, the true dark will return to the Earth. People will step outside and feel a sense of relief, but it will be a hollow relief. Because when they look at the constellation Orion, they will realize that the red point is gone. The star that guided their ancestors for 10,000 years has been erased. The vacancy in the sky will be more haunting than the light ever was. The broken timeline has delivered its payload. We lived through the 0 hour. We survived the 3 months of fire. We watched the red shadows dance on our walls, but now we have to face the aftermath. We have to face a universe where the most reliable thing in our environment, the night sky, is broken. The giant is dead, the fire is cooling, and the interstellar grave is starting to form. But there is one final question that the world will be asking as the light fades. Are we truly safe? We have seen what a star at 600 light-years can do. What happens if the next one is closer? What happens if our shield is not as thick as we thought? Strap in, we are moving away from the fire and into the shield analysis. We are going to look at the radiation panic, the ozone reality, and the lethal zone of the galaxy. We are going to find out how close is too close. Welcome to Section 10, the Earth's shield, distance as our only protection. Initialize the radiation shielding protocols. Shift the briefing from the visible to the invisible. We have spent the last section staring at the light, the beauty, and the psychological trauma of the second sun. But as the plateau phase begins to fade, a new, more clinical fear will take hold of the global population. The spectacle is over, the survivalism begins. The headlines will shift from "Look at the sky" to "Is the sky killing us?" Every scientist, every doctor, and every government official will be forced to answer a single, terrifying question. Is the radiation from Betelgeuse going to trigger a mass extinction? Analyze the anatomy of the invisible threat. A supernova is not just a light show, it is the most powerful particle accelerator in the universe. When that iron core collapsed and the shockwave punched through the surface, it didn't just release photons. It released a lethal cocktail of high-energy radiation, gamma rays, X-rays, and ultra-high-energy cosmic rays. These are the bullets of the cosmos. They move at or near the speed of light, and unlike the visible light that creates red shadows, these particles have the power to strip electrons from atoms, shatter DNA, and sterilize entire planets. Do you understand the inverse square law? This is the only reason you are still alive to read this briefing. In physics, the intensity of radiation decreases with the square of the distance. If you double the distance, the radiation is 4 times weaker. If you triple the distance, it is 9 times weaker. Betelgeuse is 640 light-years away. That distance, that vast, silent vacuum of the interstellar medium, is our absolute shield. It is a wall of empty space, so thick that it dilutes the fury of the supernova until it is nothing more than a whisper by the time it reaches our upper atmosphere. Think about the lethal radius. If Betelgeuse were sitting at a distance of 30 light-years, just a few doors down in cosmic terms, this briefing would not exist. At 30 light-years, the gamma-ray flux would be so intense that it would instantly begin to bake our atmosphere. The nitrogen and oxygen in our air would be ionized, creating nitrogen oxides, NOx. These chemicals are the natural enemy of the ozone layer. Within weeks, the ozone layer, the thin blue line that protects us from the sun's ultraviolet radiation, would be stripped away. The sun, our own life giver, would turn into an executioner. The UV index would skyrocket to levels that would cause blindness in animals and terminal cancer in humans within minutes of exposure. This is what a nearby supernova looks like. It is not a light show, it is a sterilization event. But 640 light-years is the Goldilocks zone of disaster. We are close enough to see the fire, but too far to feel the heat. Access the atmospheric monitoring logs for the year of the arrival. The sensors on the International Space Station and the high-altitude balloons will record a spike in high-energy particles. There will be a measurable increase in the cosmic ray flux, but the Earth's magnetosphere, our planet's internal magnetic shield, and the thickness of our atmosphere will act as a lead apron. The radiation will hit the top of the sky, create a few extra auroras, and then dissipate. For the average person on the ground, the radiation danger is effectively zero. You will receive more radiation from a single cross-country flight or a dental X-ray than you will from the death of Betelgeuse. The crisis of misinformation, however, will be more dangerous than the radiation itself. This is the social radiation we must discuss. Despite every scientific assurance, the world will enter a state of radiophobia. People will buy anti-radiation suits that don't work. They will hide in basements. They will stop eating fresh produce for fear of cosmic contamination. The fear will be fueled by the unknown. Because the world can see the star, they assume they can feel its poison. The scientific establishment will be accused of a cover-up. Governments will be forced to deploy mobile radiation monitors in every major city just to show the public that the numbers aren't moving. We are entering an era where fear of physics is as lethal as physics itself. Analyze the long-term biological effects. While the immediate gamma-ray burst won't kill us, the cosmic rays, heavy nuclei moving at relativistic speeds, will continue to arrive for centuries. These are the laggards of the explosion. Because they are charged particles, they are deflected by the magnetic fields of space, meaning they take a zigzag path to Earth. They will arrive decades after the light has faded. Will this cause a slow rise in mutation rates over the next 1,000 years? Perhaps. Will it slightly alter the cloud cover of our planet as these particles seed ion-mediated nucleation? It's possible. We are participating in a global experiment that we did not sign up for. The Earth is being lightly dusted by the guts of a dead giant. Think about the technological shield. Our modern world is built on a fragile electronic skeleton. Satellites, power grids, and global communications are all vulnerable to solar storms. A supernova, even at 600 light-years, is like a solar storm on steroids. While the atmosphere protects our bodies, our silicon infrastructure might experience bit flips and software glitches. A high-energy particle hits a transistor in a satellite, and a 0 becomes a 1. A flight computer errors out. A banking transaction vanishes. This is the digital price of the supernova. We won't die of radiation poisoning, but our digital civilization will have to deal with a constant static from the constellation Orion. Consider the philosophical weight of the shield. For thousands of years, humans believed the Earth was the center of everything. We believed the stars were decorations put there for our benefit. But the Betelgeuse event forces us to realize that we are accidental survivors. We are only alive because the lethal radius of this specific explosion happened to end a few hundred light-years before it reached our orbit. If the star had been closer, or if our sun had been born in a more crowded neighborhood, like the center of the galaxy, life would never have had the time to evolve. Our existence is a statistical fluke, protected by the cold geometry of distance. Analyze the ozone recovery models. Even if there is a tiny dip in our ozone layer, maybe 1% or 2%, our planet's self-healing mechanisms are robust. The sun's own radiation actually helps create more ozone in the lower stratosphere. We might see a slight increase in skin sensitivity for a decade, a requirement for higher SPF sunscreen, but the biosphere will hold. The trees will keep growing. The plankton will keep photosynthesizing. The shield of Earth is not just rock and gas. It is a dynamic system that has survived thousands of nearby supernovae over the last 4 billion years. We are the descendants of survivors. Here is the expert tone reality. Distance is our only protection. In the universe, safety is just a function of empty space. We look at the supernova and feel awe, but we should feel gratitude. Gratitude for the vastness that we usually find so terrifying. The void that we fear, the empty, cold, dark millions of miles between stars, is the only thing that keeps the cosmic fire from consuming us. We are safe because space is big, and because the universe is, for the most part, empty. But as the fear of radiation fades, a new kind of grief will take its place. The world will realize that the second sun was a farewell gift. As the light continues to drop, the physical reality of the loss sets in. The radiation didn't kill us, but the void has changed us. We are looking at a sky that is about to lose its most iconic landmark. The hunter is about to be maimed forever. Access the final telemetry for Section 10. The radiation spike has passed. The magnetosphere has held. The digital bit flips have been patched. We are safe. But the constellation Orion is unrecognizable. The red point is now a faint gray smudge. The hunter's shoulder has been amputated by the laws of physics. Strap in, we are moving away from the shield and into the erasure. We are going to look at what happens when a star simply vanishes. We are going to explore the empty shoulder and the emotional hole it leaves in the human story. Welcome to Section 11, The Broken Hunter, the night Orion changed forever. Initialize the post-flash archives. Set the temporal markers to 1 year after the arrival. We have survived the 0 hour. We have lived through the 3 months of fire. We have analyzed the radiation and realized that the Earth's shield held firm. But as the light curve of the supernova finally drops below the limit of human vision, we are left with a reality that is arguably more haunting than the explosion itself. For the first time in the history of the Homo sapiens species, the night sky has been fundamentally, permanently, and visibly altered. The most recognizable constellation in the human story, Orion the Hunter, is now maimed. The left shoulder of the giant is gone. Analyze the visual void. Go outside on a crisp winter night 1 year after the event. You look toward the south, searching for the familiar hourglass shape of Orion. You see the 3 stars of the belt perfectly aligned. You see the brilliant blue-white fire of Rigel at the foot. You see Bellatrix marking the right shoulder. But when your eyes move to the top left, where a warm, orange-red glow used to sit for millions of years, there is nothing, just the cold, indifferent black of the deep vacuum. It is a celestial amputation. The symmetry that guided every navigator, every poet, and every farmer for 10,000 years has been shattered. Do you understand the emotional gravity of this erasure? This isn't just about a point of light. It is about the Lafani, eternal nature of the stars being proven a lie. For our entire history, we looked at the stars as the fixed background of our lives. They were the only things that didn't change while empires rose and fell. But now, the Wajud existence of Betelgeuse has been deleted. Every time you look up at Orion, you will feel a colish, a tiny, persistent itch in your mind that says something is missing. The constellation now looks like a broken machine, a clock with a missing gear. It is a constant, haunting reminder of the impermanence of the universe. Think about the generational gap. This is the section of the briefing that deals with the inheritors of the void. Children born after the year of the Flash will grow up in a world where Orion has only one bright shoulder. When they look at old textbooks, old movies, or old photographs, they will see a red star that they will never experience with their own eyes. They will ask their parents, what was it like to see the hunter whole? And you will have to explain the Heibat, or of a star that could cast red shadows. Betelgeuse will move from the realm of astronomy into the realm of mythology. It will become the lost star, a legend that we witnessed and they missed. We are the last generation of the old sky. Analyze the physical remnant. Is the spot truly empty? Not exactly, but for the naked eye it might as well be. Where a supergiant once stood, there is now an expanding shell of radioactive gas, a supernova remnant. At its center sits a neutron star, a ball of pure nuclear matter so dense and so small, only 20 kilometers wide, that no telescope on Earth can see it as more than a microscopic pinprick. The gas shell will eventually become a nebula, a beautiful, glowing cloud of colors like the Crab Nebula. But that process takes centuries. For the next 1,000 years, the shoulder of Orion will just be a faint gray smudge, visible only through long-exposure photography. To the human eye, it is simply a grave. The crisis of identity for the constellation Orion is profound. In ancient Egyptian mythology, Orion was Sa, the father of the gods. In Greek myth, he was the great hunter who boasted he could kill any beast. In every culture, from the Vedas to the Mayans, this constellation was a pillar of the sky. By removing Betelgeuse, the universe has dismantled a piece of human culture. We are forced to realize that the universe does not care about our constellations. They are just accidental alignments of stars at different distances, and one by one, they will all eventually fail. Betelgeuse is just the first domino to fall in our recorded history. Consider the navigational trauma. For centuries, Polynesian wayfarers, desert nomads, and early sailors used Betelgeuse as a primary marker. It was a standard candle of the sky. While modern GPS has made celestial navigation a backup skill, the loss of such a primary marker is a psychological blow to our sense of orientation. The sky feels less reliable. It feels like a map that is being slowly erased, one city at a time. The sense of cosmic order is replaced by a sense of cosmic chaos. Access the Suwara aftermath logs. What happened to the killer? The hidden companion star, Suwara, that wrecking ball that accelerated the giant's death, is likely still there, but it is now a wanderer. The supernova explosion probably kicked it out of its orbit, sending it screaming through the interstellar medium at hundreds of kilometers per second. It is a bullet star, carrying the radioactive signature of the giant it murdered. It will wander the galaxy for billions of years, a silent assassin fleeing the scene of the crime. Think about the scientific legacy left in the void. While the public feels a sense of loss, the scientific community will be drowning in data. We will have the birth certificate of a neutron star. We will have the chemical fingerprint of every element created in the blast. We will have a real-time map of how a supernova remnant expands. This data will be the gospel of astrophysics for the next 500 years. We will understand the iron wall and the neutrino drive with a precision that was impossible before. The death of Betelgeuse is the greatest gift a star could ever give to a curious species, but the price of that gift is the permanent disfigurement of our sky. Analyze the neighbor anxiety that will follow the erasure. Every time someone looks at the empty spot in Orion, their eyes will inevitably wander to other bright stars. They will look at Antares in Scorpius. They will look at Rigel at the Hunter's Foot. They will look at Eta Carini, and they will ask, who is next? The loss of Betelgeuse turns the night sky from a garden of lights into a minefield. We will no longer look at the stars with comfort. We will look at them with suspicion. We will realize that every bright point in the sky is a potential void waiting to happen. The broken hunter becomes a memento mori for the entire galaxy. Here is the emotional payoff of the briefing. The night Orion changed was the night humanity finally grew up. We stopped being children who thought the stars were fairy lights, and we became a species that understands the violent reality of the cosmos. The empty shoulder is a badge of experience. It is a scar on the sky that tells the story of our survival. We watched a god die, we felt the red shadows on our skin, and we stood our ground. The giant is gone, the hunter is broken. The recording that started in the 14th century has finally reached its final frame. But the story doesn't end with a void, because as we look at the empty spot, we are already searching for the next signal. We are already scanning the other neighbors, looking for the shivers and the plunging companions. The death of Betelgeuse wasn't an ending, it was a warning. It was the universe telling us that the active phase has begun. Strap in, we are moving away from the broken hunter and into the neighbor threat. We are going to look at the other ticking time bombs in our backyard. We are going to find out if Betelgeuse was a lone event or the first shot in a cosmic barrage. Welcome to Section 11, the neighbor threat, who is next. Initialize the stellar graveyard survey. Expand the search parameters to the immediate 3,000 light-year radius. The erasure of Betelgeuse has done more than just change the visual landscape of the night sky. It has triggered a reliability crisis in the field of modern astronomy. For over a century, the isolated evolution model was our gospel. We believed that stars, especially red supergiants, aged in a predictable, linear fashion, a slow 100,000-year crawl toward the iron wall. But the Saguaro anomaly has humiliated that assumption. We now know that a star can be murdered by a hidden companion, its timeline compressed by orders of magnitude. As we look at the empty shoulder of Orion, we are forced to turn our telescopes toward the other giants. We have to ask the question that no one wants to hear: who is the next domino to fall? Analyze the profile of Antares. Located in the heart of the constellation Scorpius, Antares is the rival of Mars, a massive red supergiant that bears a terrifying resemblance to what Betelgeuse used to be. It is approximately 550 light-years away, nearly 100 light-years closer than Betelgeuse. This is the immediate concern. If our calculations for Betelgeuse were wrong by 99,000 years, what is the margin of error for Antares? We already know Antares is a binary system. It has a small blue companion. But after the Saguaro discovery, we have to look deeper. Is there a third object? Is there a hidden wrecking ball plunging through the atmosphere of the heart of the Scorpion? If Antares were to detonate today, the 0 hour would be even more violent than Betelgeuse. The red shadows would be sharper, the second sun would be brighter, and the constellation Scorpius, like Orion, would be permanently maimed. Do you understand the systemic blind spot? For decades, we treated stars as isolated points. We did this because the math was easier, but the universe is not interested in our mathematical convenience. Over 80% of massive stars are born in multiple systems. They are locked in gravitational dances, feeding off each other, stripping mass and colliding. The discovery of Saguaro, that 5.78-year plunging killer, suggests that the Saguaro-class interaction might be a dominant mechanism for stellar death in the galaxy. We aren't looking at old age, we are looking at execution. Every red supergiant in the sky is now a suspect. Every pulsation we once called a natural burp is now being reanalyzed as a collision event. Think about the foot of Orion, Rigel. While the world was mourning Betelgeuse, the astronomers were staring at the other side of the Hunter. Rigel is a blue supergiant, sitting roughly 860 light-years away. It is significantly more powerful than Betelgeuse, burning with the light of 120,000 suns. If Rigel follows the path of its brother, the constellation Orion will not just be maimed, it will be deleted. The entire hourglass of the sky would vanish within our lifetime. The blue supernova of Rigel would be a different kind of horror, a cold, piercing ultraviolet fire that would dominate the sky for months. The neighbor threat is not limited to the red giants. It extends to every massive evolved object in our local arm of the Milky Way. Access the data on Eta Carinae. This is the monster of the south. Located 7,500 light-years away, it is too far to cast red shadows, but it is so massive, roughly 100 to 150 times the mass of our Sun, that its detonation would be a hypernova. In the 1840s, it underwent a great eruption, becoming the second brightest star in the sky before fading. We used to call this a supernova imposter event. But after Betelgeuse, we have to ask, was that eruption the result of a Saguaro-type companion hitting the core? Is Eta Carinae currently in its final NASA death throes? The neighbor threat is a multi-front war. We are surrounded by ticking time bombs, and the timers are all broken. Analyze the active phase hypothesis. There is a growing movement in the fringe of astrophysics that suggests we are entering a period of high galactic mortality. They point to the fireball surge of 2026 and the destabilization of local giants as evidence that our sector of the galaxy is undergoing a phase change. Perhaps a gravity wave from the galactic center is passing through our arm, Or perhaps the interstellar medium has become more dense, triggering these perturbations. While mainstream science remains skeptical, the empirical evidence is piling up on our doorsteps. The sky is noisy, the giants are shivering, the recording is ending for more than one star. Think about the search for the signal. After the Betelgeuse event, the SNEWS Supernova Early Warning System has been upgraded. Every neutrino detector on the planet is now hypersensitive. We are no longer just waiting for a burst, we are looking for pre-supernova neutrinos, the thermal whispers that a star emits in its final weeks of silicon burning. We have telescopes permanently locked on Antares, Rigel, and Deneb. We are looking for the shudder, the dimming, and the wake of a hidden companion. The neighbor threat has turned astronomy from a passive observation into a planetary defense mission. Consider the psychological minefield. Every time a bright star flickers, the panic will return. Is it Antares? Is it Rigel? The standard candle of the sky has been replaced by a strobe light of dread. We are a species that has lost its celestial anchor. We have realized that we live in a dynamic graveyard. The Lafani, eternal stars, were just a polite fiction we told ourselves to feel safe in the dark. The reality is that the hunter was just the first to die. The scorpion is next. The swan, Deneb, is waiting. The dog, Sirius, is a binary that will one day undergo its own transformation. Analyze the Suwara plague frequency. Statistical models now suggest that up to 30% of red supergiants might have a plunging companion that remains undetected until the final stages. This means our star charts are effectively lies. We are looking at a filtered reality. For every star we see, there is a ghost or a killer hidden in the glare. The neighbor threat is a hidden variable that has been inserted into the equation of our survival. We are no longer receivers of ancient light. We are witnesses to an active execution. We were not prepared for Betelgeuse because we were arrogant. We assumed the universe followed the linear progress of our textbooks. We assumed distance was a permanent shield and that time was on our side. But the empty shoulder of Orion is a monument to our ignorance. The neighbor threat is the universe's way of telling us to watch the shadows. Because in the glare of a giant, the killer is always invisible until the moment it strikes. The broken hunter was a lesson. The neighbor threat is the exam. We are scanning the dark, looking for the 5.78-year pulse, looking for the mass bleeding, and listening for the neutrino scream. The second sun will rise again. It is not a matter of if, but when and where. The active phase is here, and the cosmic safety of humanity has been revoked. Strap in, we are moving away from the neighbors and into the information war. We are going to look at the conspiracies, the NASA cover-ups, and the amateur revolution. We are going to find out why the truth about the stars is the hardest thing to keep secret. Welcome to Section 12, the conspiracy and the science, the information war. Initialize the digital intercept protocols. Access the global chatter logs. To understand the final hurdle of our mission, we must leave the cold vacuum of space and enter the volatile, hyper-connected world of human information. As the news of Betelgeuse's destabilization and the existence of the killer companion Suwara leaks into the public consciousness, we are witnessing the birth of a new kind of conflict, the information war. This is not a battle over physics, it is a battle over perception. In the vacuum created by the broken 100,000-year timeline, a swarm of conspiracy theories has emerged to fill the void. People are no longer asking if the star will explode. They are asking what NASA is hiding and why the slow drip of information feels like a deliberate strategy of containment. Analyze the anatomy of the cover-up narrative. It is a story as old as the Cold War, updated for the cosmic age. The logic is simple. If a star 640 light-years away, a second sun, is about to detonate, the resulting psychological shock would trigger a total collapse of the social and economic order. Markets would crash, religions would fracture, and the human engine would grind to a halt as 8 billion people stop working to stare at the sky. Therefore, the theory goes, the scientific establishment, NASA, ESA, Roscosmos, has a classification protocol for celestial events. They knew about Saguaro decades ago. They knew the Great Dimming of 2019 was a core shiver. They simply chose to feed us the dust cloud story to buy themselves, and the elites time to prepare their deep Earth bunkers. Do you understand the logic of the bunker? In the world of the conspiracy theorist, the 100,000-year safety blanket was not a mistake. It was a tactical lie. They point to the sudden surge in private space exploration and the construction of seed vaults and underground complexes as evidence that the global elite is prepositioning for a world bathed in red shadows. They claim that the neutrino alert, SNEWS, is already being intercepted and filtered through government gag orders. This is the dread factor of the information war, the belief that the truth is a luxury that the common citizen is not allowed to possess until the light is already hitting the atmosphere. But here is the scientific reality that humiliates the conspiracy, the amateur revolution. We live in an era where the monopoly on the sky has been broken. There are over 10,000 amateur astronomers across the globe with telescopes so powerful and sensors so sensitive that they rival the professional observatories of the 1990s. These are independent actors, doctors, engineers, and teachers who spend their nights tracking the radial velocity of Betelgeuse from their backyards in Australia, Arizona, and the Atacama. You cannot classify the sky. You cannot put a gag order on 10,000 independent lenses. If the neutrinos hit, or if the shock breakout begins, it will be an amateur in a backyard who breaks the news on social media before the NASA press room has even finished their coffee. The information war is being won by the citizens of the sky, not the architects of the state. Analyze the slow drip phenomenon. Why did it feel like the information came out so slowly? This is where the conspiracy meets the boredom of bureaucracy. Science does not happen in press releases. It happens in peer-reviewed journals. The collapse of the 100,000-year timeline didn't happen in a single day. It happened in a series of dense, technical papers with titles like Nonlinear Pulsations in Alpha Orionis and Interferometric Evidence of Substellar Perturbations. No one in the mainstream media reads these. They are hidden in plain sight behind academic paywalls and jargon. It takes 18 months for a technical discovery to be translated into a human headline. The slow drip isn't a cover-up, it's a translation delay. We are a species that speaks in drama, trying to understand a universe that speaks in mathematics. Access the James Webb anomaly logs. This is the real mystery that the conspiracies often miss. Since its deployment, the James Webb Space Telescope, JWST, has been revealing a universe that is far more active and violent than our previous models suggested. We are seeing early galaxy formation that defies the Big Bang timelines. We are seeing black hole FEDING at rates that shouldn't be possible. And we are seeing neighbor giants like Betelgeuse exhibiting active phase behaviors. The conspiracy theorists claim that JWST was launched specifically to watch the countdown. The scientific truth is more unsettling. We didn't know the room was on fire because we were sitting in the dark. JWST just turned on the lights, and we are terrified of what we see in the corners. Think about the institutional arrogance of the Standard Model. For 60 years, the establishment told us that stars were stable spheres. They dismissed the amateur data that suggested irregular pulsations. They ignored the fringe theorists who proposed the existence of plunging companions like Saguaro. Why? Because to admit they were wrong was to admit that our star charts are effectively a map of a graveyard. The information war is not just about NASA versus the people. It is about old science versus new reality. The truth about Betelgeuse wasn't hidden by a deep state. It was hidden by the arrogance of the textbook. Consider the digital echo chamber. In the age of AI and deepfakes, the arrival of the light will be met with aggressive skepticism. When the second sun rises, half the world will claim it is a hologram, or a Project Blue Beam psychological operation. We have reached a point in our information evolution where a universal physical reality, a supernova in the sky, will be treated as a contested political event. This is the psychological trap of Section 12. We are so used to being lied to by our institutions that we will struggle to believe our own eyes when the red shadows fall. The information war has atheized us against the ore of the universe. Analyze the SNEWS integrity. As we discussed in Section 5, the Supernova Early Warning System is an automated multinational network, but in the information war, even data is a target. There are concerns that sophisticated hackers could trigger a false alert, causing global panic for a 0 hour that never comes. Or conversely, a DDoS attack on the neutrino servers could delay the alert, robbing us of our 24-hour window. The neutrino guard is our only objective messenger, but it is tied to a vulnerable digital spine. Our cosmic awareness is only as strong as our cybersecurity. Here is the high-retention payoff. The real conspiracy is not that NASA is hiding the explosion. The real conspiracy is that we have been lulled into a false sense of permanence. We have built a civilization on the assumption that the sky is static. We have ignored the 600-year recording because we didn't want to face the impermanence of our world. The information war is the sound of that comfortable lie being torn apart by the uncomfortable truth of a dying giant. The Suwara killer is not a government secret. It is a universal reality that we were too arrogant to see. The slow drip is over. The amateur revolution has mapped the wake of the assassin. The James Webb has revealed the active phase of our neighborhood. We are no longer guessing in the dark. We are waiting in the light. But as the information war rages on the ground, the final countdown is happening in the stars. All the chatter, all the theories, and all the classification protocols will mean nothing the moment the first neutrino hits the ice at the South Pole. Strap in. We are moving away from the lies of men and into the truth of the void. We are going to enter the final briefing. We are going to look at the 24-hour checklist, the final payoff, and the countdown that is already at 0. Welcome to Section 13, Final Briefing, the Countdown. Initialize the end of mission protocols. Lock all global synchronization clocks. We have reached the final stage of this briefing. We have traveled from the crowded sidewalks of Fifth Avenue to the iron-choked heart of a dying giant. We have unmasked the Suwara killer, survived the 3 months of fire, and analyzed the neighbor threat that surrounds our fragile rock. Now, the time for theoretical models and academic debates is over. We are entering the live window. Every piece of data we have discussed leads to this singular point in human history, the countdown. But this is a countdown unlike any other, because in the universe of general relativity, the timer hit 0 6 centuries ago. We are simply the generation that is standing at the finish line, waiting for the news to arrive. Analyze the recording theory one last time. This is the Bari, heavy reality that must anchor our conclusion. When you look up at Betelgeuse tonight, you are not looking at a star. You are looking at a ghost. You are watching a high-definition recording that was filmed in the year 1386. Every pulse, every shiver, and every dimming event we see is a message from the Middle Ages. The Great Dimming of 2019. That was a performance from the 14th century. The Suwara plunge of 2026. That is ancient history playing out in the present tense. This is the cosmic dread of our existence. We are chronologically blind. For all we know, the neutron star was born when the Black Death was still ravaging Europe. We are just the audience in a 600-year-old cinema, waiting for the final scene to flicker across the sky. Do you understand the 0-hour payoff? Access the 24-hour checklist. This is the core of the final briefing. Imagine the moment the SNEWS Supernova Early Warning System triggers. It will not be a gradual leak of information. It will be a binary event. 1 second the world is normal. The next second, every neutrino detector on Earth, Super Kamiok and Ice Cube, Snow Plus, is screaming. Hour 0, the ghost storm. Trillions of neutrinos from the collapsed iron core pass through your body. You feel nothing. But beneath the mountains of Japan, the blue Cherenkov sparks fill the tanks. The automated alert is sent. Within 5 minutes, every astronomer on the planet is awake. Hour 2, the social collapse. The news hits the digital spine. The information war we discussed in section 12 reaches its boiling point. Panic, awe, and religious fervor collide. The markets freeze. People look at the hunter's shoulder and see nothing yet. The light is still fighting its way out of the star's radioactive guts. Hour 12, the collective breath. The world becomes a single audience. The what would you do question becomes the only thing that matters. Would you call the person you haven't spoken to in years? Would you sit on your roof with a bottle of wine and wait for the red shadows? In this 12-hour window, the ego of humanity is stripped away. We are no longer citizens of nations. We are witnesses of the void. Hour 24, the arrival. The first photon crosses the atmosphere. The second sun rises. The recording finally hits the climax. This is the moment the hunter is amputated. This is the moment the broken timeline is fulfilled. Think about the psychological payoff of that 24-hour window. It is the most honest time in human history. We will be living in a world where we know the old sky is dead, but the new sky hasn't arrived. It is a state of purgatory. And in that purgatory, we will finally understand our wajud existence. We are a flash of consciousness in a universe that operates on geological timelines. We are the observers that give the supernova its meaning. Without us, the death of Betelgeuse is just a thermodynamic event. With us, it is a tragedy, a spectacle, and a marker of time. Analyze the active phase of our galaxy. As we wrap up this mission, we must look beyond Orion. The Suwara anomaly has proven that we have been misreading the stars. We are entering an era of stellar mortality. The galactic neighborhood is shifting. Antares, Rigel, Deneb, and Eta Carinae are all watching. They are part of the same barrage. We are no longer living in a static museum of lights. We are living in a firing range. The broken hunter was the first warning shot. The second sun is the flare that signals the start of the active phase. Consider the emotional trigger of the empty sky. This is the final Bari thought I want to leave you with. For all of human history, we have been children of Orion. The 3 stars of the belt and the red shoulder have been our nighttime guardians. They were there when we first walked out of the caves. They were there when we built the pyramids. They were there when we split the atom. And soon, perhaps tomorrow, perhaps in 100 years, they will be gone. We will be the first generation of the void. We will have to navigate a world that is orphaned by its most famous constellation. The grief we will feel for a star 600 light-years away is the ultimate proof of our cosmic connection. We are made of the same nuclear ash that is currently exploding in the shoulder of the hunter. We are mourning our own ancestors. Access the final payoff logic. Why did we tell this story? Why did we spend 20,000 words analyzing a star that might already be dead? Because present tense is a polite fiction. We live in a world of delays. We see the past and call it the present. We hear the echoes and call them voices. Betelgeuse is the great teacher of this reality. It teaches us that safety is an illusion of distance. It teaches us that permanence is an illusion of time. And it teaches us that the sky is not a roof, it is a recording. Think about the closing visual. Go back to Fifth Avenue. The second sun has been in the sky for 3 months. It is now starting to fade. The red shadows are lengthening for the final time. The world has changed. People don't look at the sky with awe anymore. They look at it with knowledge. They know that the hunter is gone. They know that the neighbor threat is real. And they know that their own timeline is just as fragile as the 100,000-year lie they were once told. The cosmic dread has been internalized. It is no longer a dread of the unknown. It is a respect for the inevitable. Analyze the final call to action. This is not just a video script. It is a briefing for the end of an era. Ask the audience, what would you do in those 24 hours? Force them to confront the brittle window. Make them realize that they are receivers of a 600-year-old message. The ink is burning. The neutrinos are moving. The Suwara killer has done its work. The only thing left is for the light to reach your eyes. Here is the closing statement that will anchor the soul of this script. We spent centuries believing the stars were our guardians. We called them Lafani, eternal. We used them to find our way home, but today we know the truth. The stars are not guardians. They are actors in a drama that started before we were born. Betelgeuse is not a star. It is a 600-year-old recording of a death rattle. The shoulder of Orion is already empty. We are just waiting for the news to arrive. So look up tonight. Find the red point in the hunter's shoulder. Look at it not with comfort but with Hebat, awe, because you are watching a ghost. And somewhere in the cold, dark vacuum between here and there, the second sun is already screaming toward you. The countdown isn't just for the star. The countdown is for our understanding of our place in the void. Betelgeuse is counting down. Saguaro has struck. The iron core has collapsed. The neutrinos are passing through you right now. Are you ready for the day the sun rises twice?